Hello, grade 11s. Here's our next section, which is 2.2 trig ratios. So what we're going to look at here is now how sine, cos, and tan are related to these angles of a coordinate plane. So what I've drawn here for you is a triangle in quadrant 1. And notice how the bottom of the triangle would be along the x-axis. The side of the triangle would run in the y direction, so we'd call that y. And then the hypotenuse, we call r for the radius, because later on this is going to end up making a circle, so the radius is that diagonal piece. Now, if we consider the angle right here, so theta is our angle, let's think about how y and x and r are related to the opposite, the adjacent, and the hypotenuse. So from theta, the y would be the opposite, the x would be the adjacent, and the r would be the hypotenuse. Now that we know this, we can use those to come up with our sine, cos, and tan ratios. So again, this triangle that we've created is called a reference triangle. And we know that sine is opposite over hypotenuse. We know that cos is adjacent over hypotenuse. And we know that tan is opposite over adjacent. So if we're thinking of it in terms of x, y, and r, that means sine would actually be y over r, cos would be x over r, and tan would be y over x. Also remember that with any right triangle, a squared plus b squared equals c squared, which means that x squared plus y squared would equal r squared, because it's really the same thing, just different names. Now we can also use this thing called the cast rule to tell you what trig functions are positive in each quadrant. So remember that our quadrants go 1, 2, 3, and 4. Now, I know your textbook says the cast rule, but I actually prefer saying a smart trig class. So a smart trig class. So what this means is in the A quadrant, all trig ratios are positive. In the S quadrant, only sine is positive. In the T quadrant, only tan is positive. And in the C quadrant, only cosine is positive. So again, it's a smart trig class, and it tells you which trig functions are positive in each quadrant. So let's try example 1. Here we have a point that's at -8 and +15. So that would be somewhere over here in quadrant 2. If I make a triangle out of this, again, I'm making a line from the origin, and then a dashed line down to the nearest x-axis. The -8 is on the x, so that would be over here, and the 15 is on the y, so that would be here. So now we'd have our triangle labeled. The angle that we're looking at is the reference angle, so the angle would be right in here. Again, that's my reference angle. Now we also need to find the hypotenuse. So we're going to use a squared plus b squared equals c squared to do that. So just read through how I went through a squared plus b squared equals c squared, but I ended up with 17. So 17 is the hypotenuse. Now we need to find sine, cos, and tan for this angle. So we'll start with sine theta. Sine is opposite, so the opposite of the angle would be 15, and the hypotenuse would be 17. So sine is 15 over 17. Then we're going to look at cosine. Cosine is adjacent over hypotenuse, so here the adjacent is -8, and the hypotenuse is 17. Then we'll go to tan. Tan is opposite, which is 15, over adjacent, which is -18. Now you always have to check that these fractions are in lowest terms and that there's no roots in the denominator. We also have to check that the signs work according to our little rule, a smart trig class. So according to a smart trig class, in quadrant 2, where our triangle is located, only sine should be positive. The other ones should be negative. And if you look at your answers, that's true. So sine is positive because it's in quadrant 2, but cos and tan are negative in quadrant 2. I'd like you to try the your turn on your own. Now the answer is shown here, so try to pause the video, do as much as you can on your own, and then take a look at the answer when you're finished. So now we're going to look at example 2. So we're going to determine the exact value of a trig ratio. Anytime you hear exact value, you should think your special triangles. So let's say we've got cos of 135. Always draw this out first. So 135 degrees is into quadrant 2. So this would be 135 degrees. And that would leave us with a reference triangle over here with a 45-degree reference angle, because 180 minus 135 is 45. So since I have this 45, 45, 90 triangle, remember that the side lengths of 45, 45, 90 are 1, 1, square root 2. So if I'm looking for cos 135, cos is adjacent, which is 1, over hypotenuse, which is root 2. Now, remember you can't have that root in the denominator, so I'm going to multiply both out by root 2. So we end up with root 2 over 2. But we have to check our sign, because technically this 1 on the x-axis would be negative, since it's in the negative x direction, which would have turned our whole fraction negative. And you should remember that according to a smart trig class, only sine is positive in quadrant 2, so this should be negative since it's cosine. Let's try the same thing here with the your turn. This time it's 240 degrees, so 240 degrees would be located in quadrant 3. And in quadrant 3, it would be 60 degrees past 180, so we're looking at a 60-degree reference angle. And again, I'm going to make my triangle. So if it's a 60, 30, 90 triangle, that means my side lengths are 1, 2, and square root 3. Remember that the 1 would be across from the 30-degree angle because it's the smallest. So now we want sine. So sine is opposite. So in this case, the opposite is root 3 over the hypotenuse, which is 2. But again, we have to check. According to a smart trig class, only tan is positive in quadrant 3. So this sine 240 needs to be negative. Again, it has to be negative because it's in quadrant 3. And technically, it would be the negative would be with the root 3 and the 1. They'd both be negative because it's on the negative x and the negative y axis. The 2, since it's a radius, is actually always positive. So technically the negative's with the root 3. One last example here, example 3. We have an angle in quadrant 3, and we know that cos is negative 3 over 4. So always draw it. So we're starting here in quadrant 3, so my angle is going to be down here. If I make my triangle, my 90 would be here. And again, I know that cos is negative 3 over 4. So that means the negative 3 is your adjacent, and the 4 is the hypotenuse. So I'm going to label the adjacent as negative 3 and the hypotenuse as 4. Now we need to use a squared plus b squared equals c squared to find the other side length. So if you pause here and follow through my a squared plus b squared equals c squared, you'll end up with root 7. Now I'm actually going to put a negative in front of that root 7 because it's on the downwards part of the y-axis, so it would be a negative value. Next, we want to find the exact values of sine and tan. So sine of this angle would be opposite, so negative root 7 over hypotenuse, which is 4. So that would be our sine value. We don't need to type it in our calculators because we want the answer to be exact. Then we'll find tan. So tan is opposite, so negative root 7 over adjacent, so negative 3. Now the only thing here is that there's the double negative, so the root 7 over 3 as a positive would be your final answer. And you can just check that because of a smart trig class, the tan value should be positive in quadrant 3. Here's the your turn for that one. So again, please pause the video, try it yourself, and then just take a look back at the answer here as you need it. And here are the textbook questions for today. Please only do A and C for 1, 2, 3, and 5, but do all of 6 and 11. Have a great day.